Welcome back to ArmanisMath. Today we're going to review Chapter 2. All right, Chapter 2, at the beginning of it, we looked at linear and quadratic functions. So I believe this was a warm-up here that we had. We're not going to spend that much time, obviously, in each single section. As you could tell, this is a review. So basically, I'm going to pick and choose certain items. Let's say, for example, I want to talk about number 2 here. What do you think is happening to number 2 in terms of a transformation? What's happening to this function here? Is it being shifted? Is it being shrunk or stretched? What kind of stretch? Are we talking about horizontal, vertical stretch? I need to see a lot of participation today. The more I see, the more I'm able to detect if there is something that I need to reteach or show or explain. So whiteboard would be the optimum. Also, don't forget to use the chat or the live stream comments as well. Do not wait for your friend to answer. You answer. You give me your thoughts as well. So second one is we're talking about this one here, the one that I'm having an arrow next to. This one here. Okay, the answer is that's true, Callie. It's stretched, vertically stretched by 2. So basically, you're pulling this from like a rubber, string. You're pulling it from the top, like you're basically stretching. You're saying this is going to be stretched, vertical stretch. All right. Let's move on. Polynomial functions, you know that starts from a higher degree, goes in standard form. That is, starts from the highest degree all the way to the 0 degree of the variable. And then you know that there's something called leading coefficient, which is the number next to the highest degree variable. And also you know that the degree is determined by the highest exponent. It could be hidden somewhere, but you have to shuffle things around to make it in a standard form and to see that degree. This one here is basically different types of function. The 0 function, f of x equals 0 or y equals 0. Y equals 0. What kind of line is that? I just wonder. What is y equals 0? Champions, focus. What is y equals 0 function? What is that? What kind of graph is that? Good job, Jordan. It is a line. But what horizontal line? Thank you so much, George. And what kind of horizontal line? What do you think this actually overlays? What line? If you were to graph y equals 0. Exactly. It's on top of the x-axis itself. The x-axis has a label, x-axis. But the equation of it is of y equals 0. Also in reverse, x equals 0 for the y-axis. Constant is, let's say, y equals 2. That's also a function because it's a horizontal line. You could use the vertical line test. We also have the y equals mx plus b or ax plus b if you're talking about the regression line and the correlation. And finally, we have the ax squared plus bx plus c, which is a quadratic function. It could happen that they gave you something like this where you would come up with a linear function. They have to be very specific, and they give you two points. From the points, you're going to come up with the slope of the points and then put that in a point slope to come up with the equation for that linear function. I did paste the link for the live, so make sure that you keep track of that just in case if you need to review afterwards. Rate of change of the slope is the change of y over the change of x, or delta y over delta x, which is y2 minus y1 over x2 minus x1. And y equals mx plus b again, talking about the slope, positive and negative. And also the idea of the correlation here, positive correlation, negative correlation, and then there is strong and there is a weak correlation. A picture was 1,000 words. So if you have something like this, this is a bunch of data points here, the dots, and you want to see the best fit line, the best line that you can fit through the data. In this case, you see like there's something going up here if you were to graph. This is positive. This is r equals 1, very strong correlation, meaning one variable goes up, the other one goes up. let's say, for example, employment goes up and spending also goes up. That's correlation here. This one here, this one is weak correlation. This one here is like a blob of things. Data is all over the place. There's no correlation whatsoever. I cannot deduce information from here. This one here is the opposite side. 1, R here is -1 because slope is -1. And correlation in this case would be something like I have something that increases while the other item actually decreases. One variable increases, the other variable decreases. Okay, and this is a very strong correlation. So the correlation factor is between -1 and 1. If you have 0, that means no correlation. 1 or -1, very strong, depending on the sign of it, if it's positive or if it's negative. Describe the graph of this function here. What do you think you could tell me about this function here? What kind of transformation are we talking about? Please try your thoughts. Don't wait until somebody answers. There is quite a few of us here, so make sure all of us participate. Yep, that's right. Antonio, I see that. I see actually that's good information here. Who put that vertex? Kumar. That's very nice. This is actually a quadratic because the highest exponent is 2. The highest exponent is 2. It is a quadratic, and I know this is h, right? H and k. So it has a vertex at 2, 3, right? And it does also have a shifting. This is shifted to the right 2 units, as some of you have just told me, and up 3 units. What does this 2 do? What does the 2 does to the function is vertical stretch. Okay. All right. We know that if the a is positive, you look upward, happy face. If the a is negative, you look downwards for the quadratic formula, quadratic equation. The vertex form is a x minus h squared plus k, and they gave you actually two formulas here. If you want to find h, just by knowing ABC, you could find h. You don't have to look at the graph. H is going to be equal to negative b over 2a. That's going to give you h. How about k? Well, k is going to be c minus a h squared. So once you find h, you could find k without looking at a graph. Okay. So if a is positive, obviously looking upward. If a is negative, the parabola opens downward. Ali also has something about the axis of symmetry is 2. Yep, the axis of symmetry goes through the x part. You're right for the last problem. How about this one here? Let's practice this here. It says use the vertex form of the quadratic to find the vertex and axis. Some of you asked me that question on the quiz. Axis means axis of symmetry. And the axis of the graph of this quadratic. Can somebody help us here? Use the vertex form. So obviously you have to have h and k. How do you get h and k? Interesting. Can I do it without the bucket? I'm not asking to complete the square in this case, but can I do it? Vertex form. Here we go. Vertex form. Yeah. So let's see what's suggested here for us to do. It says here that I could find h because they wanted. If that's what all that they want, I'm not gonna do the extra work. If they just wanted the vertex, well, that's h and k. How do you find h? We'll just give you the equation for that, remember? How do you find k? Well, we also give the equation for that, if you guys remember. What was the equation for k again? What was the equation for k? Does anybody remember what was the equation for finding k? Looks like there's a delay in the chat here. Yep, k is No, that's H. That's H. I need K, Faith. Yep, here we go. K is a C minus AH squared. C minus AH squared. Okay, so don't forget that. C minus AK would be. Once you finish with H, you put that into this equation, find the K. So basically find your H and K. Your axis of symmetry goes through the H part of your vertex. Okay, and it's gonna look like that. You know A is 2, right? A is 2. You know that from the get-go. So you have 2 times negative 2 squared, x minus 2 squared plus 3. That's your H. That's your K. Okay, so that's for this one. Here it is again. Make sure that you know these two formulas. By the way, all this was presented previously. Obviously, we're just reviewing here. So this one here has this completing the square. So it says sketch this here. To sketch this, I'm probably gonna look at something like a vertex. It's helpful to know either the highest or the lowest point, depending on how this thing opens. Well, in this case, it's going to open downwards, so this is the maximum point. So that's going to be very helpful. So to get that, I'm going to complete the square. And once again, I complete the square by having a bucket. You complete the square when A is 1. Well, Armani A is not 1 here. Well, how do you make A 1? You take a factor, in this case, it's the negative 1, x squared. And 6x divided by negative is negative 6x. And then you leave yourself a room for a bucket. That's the bucket. That's the completing of the square. And then this negative 8 stays outside the bucket plus that portion of the bucket. How do you fill the bucket? Can somebody tell me how do you fill the bucket? Exactly. Yep. B over 2 quantity squared. That's how you fill the bucket. Fill it here, and don't forget to fill it here as well. Okay. Also, obviously, there was a lot of these on your on that video for that lesson. So make sure you review the video if you're still not sure or shaky on this information here. In this case here, it's going to give me the vertex form. Once you do the completing the square, because when you complete the square, basically you're going to end up with something minus something squared, right? That's the reason we complete the square, like something minus something being squared. In this case, it's x minus 3 being squared, plus something. So in this case, this is the K, this is the H, and you know that you have an A of negative 1. So this is the idea of completing the square. There is another time also they're asking you about the same information here, completing the square again. So just make sure that when you complete the square, A has to be 1, and you allow that by factor out whatever is next to. Basically, you're factoring out A itself. So to make sure that you have A as 1, make sure that whatever item is here, in this case to begin with, that C, you're gonna have to push it aside a little bit until you complete the square. This guy here, you have to tell him to wait aside a little bit, outside the parentheses, to complete the square, and then make sure that you compensate for it also on the other side. Another quick hint here, when you complete the square, be careful, because if A is not 1, in this case, right, it was not. So when you add the bucket here, you added, obviously, this is a B, so 4 over 2 squared, that's going to give you 2, squared is 4. But be careful because you have a 2 as A here. So in essence, if you actually put a big bracket here, you're basically adding an 8. 2 times 4 is 8. And that's why you have to subtract the 8 from this side. Okay? So whatever you add, you subtract. Because once again, if you guys remember looking at this example, when we taught this, let's say I have negative 8 plus 8. Well, that's what I want to end up. I want to end up with 0. Otherwise, I'm going to affect the value of the function. So that's why you cancel whatever you added when you do completing the square. If you're still shaky on this, please watch that video. It will help you a lot. Okay, here we go. I'm gonna go here. Same idea about completing the square. Here's a different idea. This one says find the equation of a parabola that cups up and down given the intercepts. So basically they're going to give you two intercepts, two solutions. The word intercepts to us means solutions, right? Real solutions. So if you know that you have solutions, basically you have x equals 1 as a solution because of this point here, 1 comma 0. Basically if you wanted to graph it like this, you are touching at 1. Put this here away. You're touching the axis at 1, and you're touching it at -3. Okay, then that means you have a solution. X equals 1, x equals -3. Well, from the solution, I'm gonna go I'm gonna walk backwards. Solution. Write this down, please. From solution, you're gonna go to factors. And from factors, you're actually going to go to the actual function. You're basically going to multiply to the function. So 3 things when you walk backwards. Solution is given to you. From that, you find the factors. From that, you actually multiply to get your function. We call that walking backwards, or re-engineering. You start from the solution. You're not looking for a solution. They gave you the solution. So from the solution, make sure you have a factor. From there, you just multiply to give you the function. And if they ask for it to be the cups up, it means looking up. Well, that means the a is positive, 1. And if it's go down, a is negative. Okay, this one says given a vertex and a point. A vertex and a point. So what do you do if you have a vertex and a point? Well, please watch this for a second because I think this showed up and most likely it's going to show up again on the test. What is given to me here? I'm given h and k, right? That's the vertex. And I'm given a point. The point itself means that it satisfies the equation. If you say this point is on the parabola, that means it's actually, when you plug it in, it's going to make the parabola true statement. So basically, I have x and y here given to me. So when you put the equation here, all what you have to do is fill in the information. So you know that y equals a, x minus h squared plus k, right? So basically, I have h. Make sure that's always opposite, by the way. And I have k. And I have x and I have y. How did you get x and y, Armani? Well, it's the point. They give you a point, a free point. So basically, why are we doing this one? Because if you did not do this one, you only put the h and k, you're only going to end up with something like, let's say, y equals a x minus 4 squared minus 1. Okay, now you're going to ask a question. What is a? How do you find a? Well, you find a, again, by using the point, the free point that they gave you. You plug in x and y, and that's going to give you the point. So that's what exactly they did here. They put the y, and they plugged in the x. And that gives them the a value. And once you know the a value, just plug it in. So in this case, a was 1. So that's why they put 1 here. Any question on this one, since you're probably going to see this one? Okay? Any questions on this? Okay. There is. Okay, this is the polynomial identities, which we also had a dedicated video for it. This is the difference of squares, for example. So if you have something in this format, a squared minus b squared, difference of two squares, it's a plus b times a minus b. And can somebody tell me what is here? Can somebody help me out here? Difference of squares. How would you give the factor out of this? What's the equivalence of this? What's the identity? Equals what? I know that this is what's being squared. That's right. Now I'm looking for the two factors, the two parentheses basically. Good job there that you guys are doing here. I'm looking for these two. Look, I'm looking for these two. So what are these two factors once you see that? Here we go. 7x minus 4y's, 7x plus 4y's. All right, that's different squares. Good job there. Square of a sum. That's a little bit different. Square of a sum is not the same as that. So this says a plus b quantity squared. Well, in this case, you're going to square the first item or term plus 2 times first times second plus the second term being squared. So let's take an example on this. And again, you should have plenty of this on your video that we had for that lesson. But what do you think I'm going to do here? Somebody help me out here. What would this give me? Don't wait for your friend. You also try it. So it's going to be 2x. Don't forget that the 2x, the whole thing is squared. Don't forget that. Plus, I'm going to use the same sign here, right? Plus 2 times the first item, that's 2x, times the second term, which is the y, plus Kumar, don't forget the y's as well. So we've got 3y's quantity squared, not just the 3. And you just have to find out this is 4x squared plus 2 times 2 is 4 times 3. 4 times 3 is 12, x and y, plus 9y squared. Any need on reviewing this, make sure that you review that video. It should help you with that. Soap comes in handy when we do cubes. Just like the cube bar of soap that sometimes we have, this is it. Difference of cubes, we use soap for that. So if you have a difference, which means subtraction, you basically have to have same, opposite, always positive. I am talking about the signs. Same sign as you start with, opposite of what you began with, and then always positive like that. You take two parentheses, the first item minus the second, and then the first item squared plus the first times the second. Remember, this is no 2 here. And then there's a second term being squared. And a quick example on this one would be here. How do I factor this out? Somebody help me out here. Okay, multiple users are typing. That's my happy moments. Are we gonna have to speed up a little bit here, you guys? Okay. Okay, I know I have. What should I put here? What's the item being cubed? 2 is being cubed, and the m is being cubed minus the 3. Good job there. And then it's going to be 2m squared opposite, which is plus 2m times 3. And then always positive would be that 3 squared. Okay, and you factor this out, find out what's going on here. This is 4m squared. This is 6m's. This is 9. That is times 2m's minus 3. Okay, are we good? Are we good here? Again, if any reason for this you need to review, make sure that you take a look at that. Some of cubes are the same. Remember to use soap as well. I'm done with this. And let's see if I could do 2 is I probably advise you to look at that 2 I would look at that video for the power. It's a short video, so that's why I'm not going to spend that much time on it here. So this is 2-3 here. This is 2-3, and this is polynomial functions of higher degree. The warm-up is here. If you want to spend time and do that afterwards, you're more than welcome to do it. Again, the terms, standard form, we talked about the leading coefficient. And this one here It says somebody was saying, wait, no. Where did the 2 come from? It was 8 cubed. 2 times 2 times 2. Okay, got you. Okay. Somebody was helping somebody else. Okay, this one says, describe the transformation on this function. Remember, this is higher degree, meaning not the second like quadratic, not the third like cubic. Now it's like 4 and 5 and stuff. So now this is the fourth quintic. Function. So can somebody tell me what's happening here in terms of transformation? Is this going up, left, and right? I see somebody saying reflected upside down. That is true, Jordan. It is reflected. And how about the 2? What is going on with this 2? Here we go. You said it's going to the right. It is going to the right 2 units and going up 5 units, and it's reflected. And basically, it's going to look like the red one here. Okay, we do use a limit notation in our class to get us ready for calc. Limit as x approaches infinity, or a number of the function, it's going to give you a value for that function. End behavior depends on 2 things. Does anybody recall? End behavior depends on 2 things. The degree, that's true. And what else? And the leading coefficient. That's it. Degree and leading coefficient. If it's an odd degree, in this case, this is an odd degree, obviously, because the endings disagree, right? The endings are odd with each other. So I'm assuming here, I'm not assuming, actually, I know this is x cubed. The ending is odd, so there are going to be different opinions here, and one is going to go up, one is going to go down. If the leading coefficient is positive, like here, positive, I'm going to end it positive. If you end positive, the other guy does not agree, obviously you're going to start negative. This one is the other way around. This is negative x cubed, so you're going to end the negative. If you end negative, the other guy does not agree, so you're going to have to start positive. If you have an even degree, obviously, in this case, this is actually to the 4th, quintic to the 4th, and this is positive, so both ends are going to end together because they're even, they kind of agree, and then here they also agree to go together on the negative direction. Okay, so let's see if you could help me. This idea, it says find the zeros of this polynomial. To find the zero of a cubic for now, before you do actually the synthetic or long division, you actually have to factor out. You basically have to chop this into quadratic, because quadratic I know how to diamond and factor out. This one I don't know. So that's, what do you think I'm going to pull out here as a common factor to reduce this thing from cubic to quadratic? I'm going to pull out the 2, that's common, and I'm also going to pull out 1x's. So 2x is going to go out. 2x is going to go out as a common factor, which again is going to reduce this interesting cubic into something that is squared, right? It's going to be x squared here, plus dot 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 dot. And once you do that, you find yourself looking at this quadratic, and you just have to diamond the quadratic once you do that, and you will find yourself looking at 3 different solutions. Well, that's not surprising, because the degree was 3. I'm expecting to see 3 solutions. Multiplicity is another idea which will definitely come in handy on the test. If you have an odd multiplicity, you're actually going to cross the x-axis. It's a real 0, you're going to cross the x-axis. If you have an even multiplicity, you're not going to cross. You basically are going to touch, or as it's referred to in math, you kiss the axis and leave. So here's an example here. I have a function, and it says sketch it. Sketch it doesn't mean graph it. It just means basically just come up with the main idea of the graph. Okay? So if I wanted to kind of just main idea of this graph, first of all, I know that I'm going to have how many zeros? How many solutions do you think I'm expecting here? What's the degree for this function? What's the degree for this function? Come on, champions. Okay, I've seen that, so let me just put a pause on this. Yes, here we go. Gavin. Do you remember that, Gavin? That's good. Good for you. Gavin is right, actually. Gavin is the only one right here. There is 3 here, which most of you saw that. But there's also another 2 here, right? So 3 and 2. You're basically looking for 5 different solutions. Yeah, not just 3. So keep that in mind, you guys. Because if you actually were to multiply this out, if I were to multiply this out, which is going to give me, this going to end up with x cubed, and this dude is going to give you x squared. Well, if you multiply them out, you're going to get x to the 5th. So you're expecting 5 real solutions. Now, what's going on here with multiplicity? Well, let's take a look. Where do you think I'm touching the axis here? Where do you think I'm touching the x-axis? What points? Let's focus, guys. Where do you think I'm touching the x-axis here? Where's my solution? Where's my intercepts? I'm touching at -2. That's very true. I'm touching here at -2. And I'm also touching at 1. Yep. That's exactly what's going on. Now, for me to sketch, remember, they don't want you to graph, just sketch. So basically, if I want to sketch this, and I know that this is an even, right? So I'm actually gonna touch and leave this spot here. I'm not gonna go through the axis. And perhaps something like this, something like that. And at -2, I have to go through the axis because the multiplicity is what? Is odd. Odd, I go through it. So I'm not sure how you're gonna put that in, like something that tells you that you go through the axis here. And even, I just have to touch and leave. So this is 2. That means I'm just going to touch and leave. I can't go through the axis. So that's kind of a basic sketch. I'm not graphing. I don't have a graphing calculator. I don't have Desmos. I'm just basically sketching it. Okay. The blah, blah, blah inside is not really my concern at the moment as much as this value here. There is a way for you to know this particular point, by the way. This particular point. If you substitute x0, if you say this is 0, that's a 2 squared, and this is a 0, that's 1 squared. So 2 squared is how much? What is 2 squared? I'm sorry, 2 cubed. That's 8. 2 cubed is 8 times 1. So at 8 here, you're touching basically that y-axis. If you want to be more careful about that place. So that spot's going to be 0, 8. But this is I'm not going to touch. This I'm going to just touch and leave. This one is going to go through because of the multiplicity. The idea of ending up in different coordinates, quadrants, I should say, was also presented. What do you think is going to be my result for number 4? Which quadrant I'm going to end up with number 4? Come on, you guys, get ready for this coming quiz. Which quadrant do you think I'm going to land for number 4? And I have, most likely, I'm going to have 2 quadrants, right? Jordan, it's right. That's one of them. Natasha is right. That's one of them. And Jordan, here we go. That makes sense now. Yep, you're going to end up in 3 and 4. Quadrant 3 and 4. This is idea of finding the zeros or intercepts, and this one says find the real zeros of this cubic function. Once again, I don't know really cubic. I know quadratic, so that's why I kind of factor the x out, and then I'm going to take this and diamond x squared minus x plus 2 using the diamond for that. Okay. Same thing here, and this is the identities come in handy here. How do you think, what do you call that thing that we actually used to factor this out? Does anybody recall? We just looked at that briefly. What do we call this thing here? What do we call this identity? Difference of squares, exactly. I've got x squared minus 1. Well, this is going to equal to x minus 1 and x plus 1. Okay, that's why I showed you the factors of these before we started here. Here's another one. This one is interesting because this says given the zeros. Please pay attention. This is given the zeros. They're not asking you for solutions. They gave you the solutions. I've got -2, I've got -1 as a solution, and I've got 1 and 2. Well, guess what? From the solution, remember what I just said, walking backwards? So from the solution, you come up with factors. From factors, you multiply to give you the function. So, but when you multiply, especially when you see things like this, your eyes should help you recognize some shortcuts. Because I'm not going to just sit there and multiply this together once I finish and multiply it by that. Once I finish, multiply it by this. That's going to be cumbersome. So try to look for some shortcuts. So they're pointing out here, why do you think I picked x plus 2 and x minus 2? If I want to multiply x plus 2 times x minus 2, what would I get? Does anybody recall? We just talked about that. I am multiplying Ali. So I'm not adding, actually. I'm multiplying. I'm supposed to multiply these factors to come up with... it's okay. To come up with... but why did I pick x plus 2 and x minus 2? Why these two I picked? Why I grouped them together? Why? Must be a reason. Come on, you guys. The factors of what? Does anybody know? The factors of what? What do we call that? Multiple use. Exactly. These are factors of difference of square. Look at that. These are x squared minus 4. So why do I have just to multiply this and spend time putting the box or whatever method that you're using here? Blah, 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 blah. No. I have it already. I know the shortcut. How about x plus 1, x minus 1? What kind of shortcut do you have for these two? Again, difference of squares. I'm not going to multiply this and spend time. My time is precious. So it's already been spent, and I know these are difference of squares, both of them. Now I come down here, and I could multiply these maybe one time. That's fine. Instead of multiplying this by itself, just imagine. You're multiplying this, and then whatever you get here, and then whatever you get, that's just too much. So have your eyes trained to look for these shortcuts. It will help you tremendously, okay? Same thing here, given the following zeros, and that's it for this one. Right, let's move on to tool 4. Synthetic and long division. Synthetic and long division are definitely here. Oh, that's funny. Synthetic and long division are definitely part of the test and the concepts here. At this point, by the way, I'm not picky which one you want to choose. Which one is you comfortable with, I'm okay with that. So even if it says, by the way, use long division to do this, well, it's up to you. You could use either synthetic or long. And just briefly here, let's take a quick example. If I'm dividing this, for example, if I'm dividing negative y x squared plus 2y cubed plus 25 divided by y minus 3, I want to point out that this has to be in standard form. You have to have this in a standard form, otherwise it does not work. Okay, so first thing for long division, and also synthetic, make sure there's standard form. Or what if you're missing something? Well, that's why you supply whatever you're missing by 0 times whatever the variable is, x or y, whatever the variable is. And then you go from there. One also thing about long division, remember that we do something on 3, like I count 1, 2, 3, and then you do something. Does anybody recall what that something is? Change the sign, exactly. So here, remember to change the sign. Or alternatively, obviously, you have to put negative times the entire thing, right? Negative times the entire thing. Or change the sign. So I would change the sign, since some of us actually, some of us forget to distribute this negative, so just plan that in your brain. You just change the sign for the entire row and you should be golden. Remember that whatever is left here is called the remainder. So the way you write it is the quotient plus the remainder. Okay, this is a long division. Synthetic would be a little bit easier, and again, it depends on your flavor, but I happen to be liking synthetic more. Again, you gotta be in standard form. Do you think I'm missing something here? Do you think I'm missing something here if I want to start this problem? Exactly, I'm missing x squared. Well, you supply that, right? You put 0x squared. Don't forget that. So put that in standard form. Also, synthetic division, you really have to pay attention to one item. When you say x, like you're dividing by this divisor, you basically have to say, you have to solve for the a. And the a is basically the x here. So the x, the a term. You put x plus 2 equals 0. Subtract from both sides. X equals -2. This is the a term. You call this is a term. That's the term that you're going to put here. So for synthetic, I know it's easy. The setup of it is a little bit easy, but don't forget that this a is very important. You don't take it the way it is as a long division. You have to change this guy to, you basically have to solve it. Set that equal to 0 and solve it, and then that's the a term. Make sure that that's what you do for synthetic. Also leave yourself a room for a line here, and you multiply. The first item drops the way it is. And then you multiply. You multiply, and then you put the answer diagonally from it. Add, multiply again, put diagonally, and then your remainder would be here. Okay, let's see what's going on down here. Same thing here, and here. Okay. So the remainder theorem, this is very easy. This one says if you're given, if the polynomial f of p of x is divided by x minus a, then the remainder r is p. I don't know what to say about this one. It's kind of self-explanatory. It's very easy, very simple. So for example here, use synthetic to evaluate the given. So for x equals 2, well, I put 2 for x. Like I put actually 2 for x. Every x would be 2. And you just have to plug in 2 for x. And you're going to end up with 41. So the remainder is 41. You're basically substituting as 41. Okay. How about this one here? Okay. Let's see the last one here, which we discussed not too long ago. Rational equations. In rational equations, remember that you have to multiply by what? Does anybody recall? You multiply by what to get rid of what? What's really bothering us in rational? Exactly, you want to get rid of that denominator, okay? So some of these are very self-explanatory. I mean, this is just simplifying. So make sure that you use the either diamond or the identities that we talked about to simplify. But when it comes to solving, you really have to get rid of this denominator. It's helpful if you see it here and you're able to factor things out. But if not, then you really have to multiply everybody by that least common denominator. In this case, it's x. What do you think I'm going to multiply by here? X minus 3. Everybody's going to get that. Everyone who lives there. How about, let's say, remember that picture? That's funny. How about here? What are you going to multiply by? You really have to pause here a second. You can't just make a quick decision here. What do you have to find out first? Here we go. I have to factor this x squared minus 4x plus 3 in hopes to get something like x minus 3 and x minus 1. I would really hope to do that, because if I do, it's going to save me time. Otherwise, I'm going to be multiplying by 4 different binomial. Who wants to do that? So luckily, we found out that in this case, x squared minus 4x plus 3, luckily, it turned out to be x minus 3, x minus 1, which means I don't have to repeat myself twice. So the least common denominator would be x minus 3, x minus 1 times every single one who lives there. And by every single one, I mean every single one. You have to multiply that by every single one of them. Okay. So specifics on the test would be things like what you have seen on the quiz. So I'm going to actually open this up right now so you actually can take a look at it as well. I'm talking about the quiz. And while I'm doing this, if you have any question for me, make sure that you stick around maybe for a couple minutes until we finish this here. They will be opened with the incorrect, showing you the incorrect answers, okay? So at least you would know what you have missed. Okay, I just did that. So if you definitely use that quiz as a tool for you to study, I would use this also this video. Make sure that you have a link to it. Most likely I'm going to post that for you guys, not publicly. So make sure you have access to that. Okay, this should conclude our review today. Good luck and be blessed.